Welcome to Brain Vision.
In this exercise, we have a spool of thread that has a radius r1 that's involved by end caps that have a radius r2. The mass of the whole system is m, and the moment of inertia around its center of mass is I. And the thread starts to be unwound by a force T that points to the right, as shown in the figure. And the whole spool rolls without slipping on a surface upon which it lies. And our goal is to show that the magnitude of the friction force between the surface and the spool of thread is T times I plus M R1 R2 divided by I plus M R2 squared. Okay, so in order to show this, I'm gonna write both the equation, the force equation and the torque equation for the spool of thread. So I'm gonna assume that the friction force between the surface and the spool of thread is pointing to the left. If it's not pointing to the left, then there's no problem, because in the result we'll just get an extra minus sign. If the sign is positive, then F is in fact pointing to the left. Notice that the total force that acts upon the spool is T minus F, and this is the total magnitude of the force in the x direction, and this, according to Newton's law, is equal to m times the acceleration. So this means that the acceleration of the center of mass is equal to T minus F divided by m. Okay, so now we can use the torque equation. Now let me just first highlight the acceleration. That's going to be useful for us. And now I can use the torque equation. So the torque, notice that the torque is positive for the friction force, because it causes the spool to rotate clockwise, while the force T causes it to rotate counterclockwise. So the total torque is F times the distance between the point where the force is applied and the center of mass, which is R2, minus T R1, and this is equal to I times the acceleration of the angular acceleration. Now the angular acceleration is just the acceleration of the center of mass divided by the outer radius of the spool, which is R2. So I'm just gonna substitute A into this last equation. So we have F R2 minus T R1. This is equal to I times A, which is TF minus divided by M. Sorry, T minus F divided by M. And now I'm gonna try to isolate F. So I have F R2. Actually, first of all, I'm gonna multiply both sides by M R2. So I have F M R2 squared minus T M R1 R2. And this is equal to I T minus F. So F times I plus M R2 squared is equal to T I plus M R1 R2. And if we divide both sides by I plus M R2 squared, we get that F is equal to T I plus M R1 R2 divided by I plus M R2 squared. And this is the result we wanted to find, and the answer to our exercise.